This is Pythagorean Theorem, Part 2. And if you remember from the last video, Pythagorean Theorem is a squared plus b squared equals c squared. Today we're going to be dealing with just the coordinate plane. If you want worksheets to practice after this video is over, what you want to look up on the internet is distance formula worksheets. Now, there isn't distance formula equation. You're going to ignore that because it's not used on the GED. If you see the distance formula, it looks like this. That is not used on the GED. Ignore it. Don't practice it. You'll use it later on in college algebra. Now, I told you we're going to be dealing with the coordinate plane, XY grid, whatever you want to call it, coordinate grid. Now, for the coordinate plane, you're always going to have A and B, and you're always going to be finding C. So that makes it a lot easier because you're always going to be using this formula, not the C minus like we were using on the last video. So you're always going to have these two, so you're always going to be adding them together. So for example, they might give you a problem that just gives you two dots on a coordinate grid. Say they give you those two dots. So first off, your first instinct is to go over here and look at these numbers over here and to look at these numbers over here. Those are only important when you're graphing lines, linear equations, and functions. For Pythagorean theorem, those numbers really you can only use them if you're wanting to know how many blocks there are in between that block, that dot, and that dot. So remember, they're going to ask the question, the distance between points. Anytime they use that word distance, it's not going to be about functions. It's not going to be about linear equations. It's going to be about Pythagorean theorem. Sometimes they're just going to put two dots on your graph. Sometimes they're going to connect those two dots. And they're going to say, how long is this line? So it doesn't look like a Pythagorean theorem problem, but it actually is. It's hidden. So the first thing you got to realize is anytime you've got an angled line, a line segment on a coordinate plane, and they're asking for distance or length, they could ask for that too. It's the same thing. What's the length of this line right here? They're talking about Pythagorean theorem, and here's why. If you take this dot and you bring it down the point where it's even on the graph with this dot, and then you connect those 2 points, you've created a right triangle. So here's your right angle. So the way you solve that is you count your blocks. It has nothing to do with these numbers over here. So you're talking about 1 block, 2 blocks, 3 blocks. So that side of the right triangle is 3. So that would be our A or our B. It doesn't matter. Then you count the bottom. 1, 2, 3, 4. Now hopefully you'll get a problem that's this easy and you remember what I taught you on part 1. And you'll notice that this is a 3, 4, 5 triangle. I'm just going to go ahead and solve it just in case you want to see how that goes. So that side of the triangle is 3, so we square that. That side of the triangle is 4, square that, gives us c squared. Punch that in the calculator, it's going to give you 25. Take the square root of both sides, and that's going to give you 5. So that's a 3, 4, 5 triangle. There's another example they might give you. Okay, again, they might just give you these two dots, or they might give you a line that goes in between those two dots. Either way, they're going to ask for the length of that line segment or the distance between those 2 points on the graph. So the first thing you have to do is count down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that side of our triangle is going to be 12. Then count over. 1, 2, 3, 4, 5. And remember, you're counting blocks, not lines. So don't start counting on this line. Don't say 1, 2, 3, 4, 5, 6, because you're always going to get one extra and you're going to get it wrong. Count blocks. So don't count where you start, count where you're moving to. So that's going to be 1, 2, 3, 4, 5. So the second side is 5. And if you remember this from your easy Pythagorean theorem problems, you'll notice it is a 5, 12, 13 triangle. So same thing applies to this that applies to the last video. So you're going to punch that in on the calculator. You're going to end up with 169. Take the square root of both sides. You're going to end up with 13. So you got a 5, 12, 13. So on to some problems. This is one of the worksheets that you'll be able to download and work along with me. So it just says find the length of each line segment using Pythagorean theorem. And then it says verify your answer using distance formula. That's what you don't have to do. So don't worry about distance formula. Just use Pythagorean theorem. Round to the nearest tenth place. It's always going to tell you what place it's going to want on the GED. So first thing we do is look at this line segment. We draw our sides. There's our right triangle. So this side's going to be 1, 2, 3. This side's going to be 1, 2, 3, 4, 5. Punch that in on the calculator. Oops. And you'll get 34. Last thing you do, take the square root. Now remember, when you punch that in on the calculator, it's not a perfect root. It's just going to come up with that number again. You're just going to get square root of 34 all over again. So you have to hit that extra button, the two arrows, called the change key. It's directly above your enter key. That's going to change square root of 34 to 5.8. Next problem. This one is only going up one block. So we're only going to go down one. So your first side is just one block. So 1 squared plus 1, 2, 3, 4, 5, 6, 7, 8 blocks. 8 squared equals c squared. That's going to give you 65 on the calculator. Take the square root. Again, that's just going to pump out square root of 65 again, I think. Then you're going to have to hit your change key. And it's going to give you 8.1 for your final answer. Go ahead and pause your video and try to do number 3 on your own. So it doesn't matter what side you go down. If you're drawing your triangles like this, it doesn't matter. If you're drawing your triangles like this, it doesn't matter. You're going to end up with the same answer. I just draw down every time just to keep it easy. So the side of this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. You punch that in, you get 52. You take the square root of both sides. It's going to give you that again. So you're going to hit the change key, and it will give you 7.2. Okay, go ahead and hit pause and try all three of these triangles, and I'm going to give you the answer to all three of them. So we've got 1, 2, 3, and it doesn't matter which number you write down first. 1, 2, 3, 4, 5, 6, 7. That's going to give you 58. The square root, and it's going to give you 7.6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives you 97. Take the square root. Hit the change key. It's going to give you 9.8. This one's going to be 2 by 2. Square root of 8. I think when you punch that in, you'll get 2 square root of 2. So you got to hit the change key, and that's going to give you 2.8. Okay, go ahead and pause your video and work these three. So this side's 1. Side's 1, 2, 3, 4, 5, 6. And I said I'd draw them down every time, and then I drew one up. It doesn't matter which way you go. That is 37. Take the square root of both sides, and C ends up being, I didn't solve this one. I'm going to solve it real quick. .08. This one's got a side of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives you 85. Take the square root of both sides, and that gives you 9.23 for your answer. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 74. Take the square root of both sides, and you get 8.6 as your answer. Just realized that's not rounded to the nearest tenth. So should have been 9.2. And I did this one wrong for you also. Remember, go back and reread your question before you turn in your answer. To not do what I just did. And once it rounded to the tenths place. So 8 tells you that you're going to go up. That's a 0, so it's going to go up to 1. So your final answer should have been 6.1 if I would have read the directions. That one was 9.2. That one's 8.6. Okay, So every now and then you'll get a question like this. You're never going to get a question like this on the GED, but they pop up on these worksheets. If it just goes straight across or straight up and down, this isn't Pythagorean theorem, so you would just simply count 1, 2, 3, so that answers 3. Down here you've got one like this. 1, 2, 3, 4, 5, 6. So if it's a straight line, you're not going to be using Pythagorean theorem. The rest of these problems are. So you'll see at the top it says distance formula. This one is different. So it's very important that you read directions, because 2 decimal places is going to give you a different answer than 1 decimal place. 2 different problems, 2 almost worked identically, 2 different answers, but depending on how they want you to round it. Go ahead and solve this one for you. 1, 2, 3, 4, 5. 1, 2, 3. That gives you 34. Take the square root. You get 5.83. So pause your video and solve this one. 1 squared plus 1, 2, 3, 4, 5, 6. If you'll notice, you just did one like this on the last page. It was 37. And take the square root, you end up with 6.08. And that's a good example, because on the last one, it was a different answer. Because on this one, they wanted you to round to the nearest tenths place, which changed it to 6.1. On this one, they wanted you to round it to 2 places, so it's 6.08. So these actually are identical problems with 2 different answers, 6.1, 6.08, just because of the way you round it. So go ahead and pause your video and solve these 2 problems. We got 5 squared plus 6 squared, which is 61. Take the square root, and you end up with 7.81. Over here you've got 1 and 7, which is 50. Take the square root, you end up with 7.07. Go ahead and pause your video and work these 3 problems. This one is 3 by 6, which is 45. Take the square root of both sides, you end up with 6.71. This one is 2 by 2. Again, same problem that we worked before, except now they wanted 2 decimal places. So when you take the square root of that, you end up with 2.83. And on the last one, right here, it had to be 2.8 because it was rounded 1 place. This one is 2 by 4, which is 20. Take the square root of 20, you end up with 4.47 as your answer. All these worksheets will be available for download with the assignment, so you can work along. If you don't have a printer, just take really good notes. That's the end of the video.